All right, welcome. Today, we're doing a technical deep dive into a complete end-to-end MLOps project built by data specialist Elias Android. The whole point? To show you how to turn raw, messy data into sharp, actionable business intelligence. We're going to break this entire architecture down, piece by piece.
You know, every great data project starts with a real-world business question. So let's imagine you're a sales director at Chevrolet. How in the world do you predict which car is going to fly off the lots next month? Getting this right is absolutely crucial for everything from inventory to marketing spend. And that's exactly the challenge this project tackles head-on.
So here's our roadmap for this breakdown. We'll start with the challenge of forecasting sales, then walk through the system's architecture, look at how data gets ingested, dive into the machine learning pipeline, see how the model is served for predictions, and finally, we'll tie it all together with a complete MLOps cycle.
First things first, in any serious data project, the very first step is to take that big, kind of vague business need and translate it into a clear, measurable, technical problem.
And there it is. The goal isn't just to build a one-off model. No, it's about building an entire automated prediction factory. From the moment the raw data comes in to the second a forecast is delivered, the whole thing needs to run on its own with no manual intervention. That's what ensures you get consistent, fast, and reliable results.
Okay, so now we get to the engineering. To build this data factory, you need a solid ecosystem of tools. Each part has a very specific job, but they all need to work together in perfect harmony. Let's look under the hood.
This right here is the backbone of the entire system. You've got four main pillars. First, an API that acts as our data source. Second, Prefect, which is like the conductor of the orchestra, handling all the workflows. Third, MLflow, which manages the entire machine learning lifecycle. And finally, another API to serve those predictions out to the world. And notice the port numbers? That makes the communication between these services super tangible.
So, where does the automation kick in? It starts with the tool Elias chose for orchestration, Prefect. Just think of it as the factory's shift manager. It wakes up on a schedule, goes to the data source, grabs the latest info, and passes it down the line. It's what guarantees the factory is always fed with fresh data, right on time.
And if Prefect is the factory manager in this architecture, then MLflow is the head of quality control and R&D. It makes sure every single model we produce is rigorously tracked and tested. Every result is reproducible. You can audit every step. This choice of tool is what really separates a simple script from a true production-grade system.
Okay, with the blueprint laid out, let's see the first stage in action: data ingestion. This is where the choice to use Prefect really starts to pay off, by making the data collection and storage process totally automated and reliable. This little bit of code from the project really captures the essence of orchestration. See that @task decorator? That one line turns a regular Python function into a monitored, reusable, and fault-tolerant building block within a much larger workflow. It's such an elegant and powerful way to build a robust pipeline. The process itself is really straightforward, but it's incredibly robust. The first task calls the API and fetches the data. If that succeeds, the second task kicks in, taking that data and dropping it into our central repository, our data lake. Prefect is the one making sure this sequence happens reliably every single time. So, our data is now clean, centralized, and ready to go. This brings us to the very heart of the project, creating the actual intelligence. This is where we hand things over to MLflow to turn that raw data into a predictive powerhouse.
Now this is where you see true governance in the machine learning process. This with MLFO.startRun block in the training script is absolutely critical to Elias's architecture. Everything that happens inside it, every hyperparameter, every performance metric, even the final model artifact, is automatically captured and versioned by MLFO. This gives you 100% reproducibility.
Of course, after we train a model, we need to ask, how good is it? The evaluate model function calculates all these key metrics. MAE, for instance, tells us on average how many cars our forecast is off by. The best part? All of these numbers are automatically logged in MLflow, so you can easily and objectively compare different model versions. And here's the payoff. This is the practical result. The newly trained model is immediately put to work to answer that original business question, and for the month of October, the AI predicts that the Chevrolet Tracker is going to be the top seller. Actionable intelligence, right there.
Look, a trained model just sitting on a server has zero business value.
The next step is absolutely critical. You have to make it accessible so other applications can actually use its predictions. This is what we call serving the model. Just look at the simplicity and power in this single line of code from the Serving API. Because we're using the MLflow model registry, loading a production-ready model is a one-liner. That model/URI points directly to the central registry, which makes deployment ridiculously simple and safe. And this is how it all comes together in the real world. Another system sends a simple JSON request with some details, the store, the car model, the month, and our API, powered by the model, shoots back a concrete prediction in milliseconds. In this case, it predicts exactly 18.75 sales for the Onyx under those conditions. All right, let's zoom back out for a second and just admire the complete machine that's been built here. What we have isn't a bunch of isolated scripts, it's a continuous, robust, and fully automated lifecycle.
So what this project really demonstrates isn't just a machine learning model, it's a masterclass in MLOps. Elias's architecture hits every key principle: automation with Prefect, reproducibility and versioning with MLflow, and clean, decoupled deployment with Flask. This is the foundation for any serious AI system that's built to last and deliver continuous value.
And that's really the bottom line here. What we've just walked through, the architecture designed by Elias Andred, is the transformation of a concept into a tangible, production-ready data product. It's a showcase of the deep technical expertise required to connect data engineering, data science, and DevOps to build solutions that actually solve problems in the business world.
And that kind of leads us to a final thought. Forecasting sales is just the beginning, right? Imagine applying this exact same blueprint to optimize pricing, predict fleet maintenance, or personalize marketing campaigns. Once you have a solid MLOps foundation like this one, the possibilities are truly endless.